And we have Mina Tesseris with us today and Ivan Koval, who are both noise experts. And Mina, I'm going to pass it off to you because we're slowly running out of time. So I want to give you guys as much time as possible.
Thanks, Sonia. Today, Ivan and I are going to be discussing noise in buildings. I'm going to be touching on the topic of noise in wood buildings and some of the sound transmission paths or noise to move through buildings. And Ivan's going to carry on and talk about testing or noise. So let's begin. I'm going to start sharing my screen here. I've got a slide presentation. And Sonia, if you could just confirm that you see my screen.
You're good. You just need to put it into presentation mode.
Okay.
You're good.
Okay. Here we go. So noise in wood buildings. So when we talk about noise transmission, there are two modes of transmission of noise through a structure. The first is airborne sound, and the second is structure-borne sound. Airborne sound is measured by what's called a sound transmission class rating. And I'm also going to talk about apparent sound transmission class rating further in this presentation, but we'll start off by just talking about sound transmission class rating. Sound transmission class rating is essentially a rating that's assigned to a solid assembly of either a floor or a wall. And so the way in which the STC rating is measured is that there's a source within one compartment, and that source will emanate noise, and the transmission is the noise is transmitted through a wall or floor, and the receiving compartment will measure the amount of noise that moves through that assembly. The STC rating, again, is a measure of the sound transmission through a opaque or a solid section of that wall or floor. It does not take into account any penetrations through the wall or floor. And as we all know, that occurs commonly in construction. There are discontinuities, there are service penetrations, and so the STC rating doesn't take that into account. So structure-borne sound can be through impact, or it can be generated by equipment. Impact sound is measured by what's called an impact insulation class rating. That rating evaluates how effectively the assembly will block impact sound from passing through it. And of course, it only applies to floor/ceiling assemblies because walls aren't subjected to impact noise. Most of the time, not always, but it's on rare occasions you will have impact noise generating through a wall. But typically, only IIC ratings, impact insulation class ratings, are assigned to wall ceiling assemblies only. Equipment will also generate sound and transmit it through the structural framing. Examples of this would be mechanical equipment, or even if a unit owner has a treadmill, for example, in their unit, or a stationary bicycle, that equipment will generate noise through the structure. And finally, the building code currently only regulates airborne sound. And so impact sound is not regulated by the Ontario Building Code. It does not address structure-borne sound. So when we talk about STC ratings, there are various levels, of course, and the current building code requirement is for the STC rating between occupied compartments and corridors to be 50 or greater. And at a level of 50, normal speech is not audible. And so we have this subjective, objective measure of sound transmission known as the STC rating. And that sort of guides a designer as to what level of soundproofing is required between spaces in the building. The building code also has a higher level of STC rating for garbage chutes and for elevator shafts, that level being STC 55. In terms of soundproofing, it is somewhat of a subjective issue in that some people are more sensitive to sound, and the smallest of sounds will bother them. And so at an STC rating of 50, normal speech is not audible, but there will be other sounds that may be audible, particularly in wood buildings where lower frequency sounds such as a stationary bicycle or even music with loud bass undertones will be heard even through an assembly that's assigned an STC rating of 50. And finally, with regard to this notion of STC ratings, I mentioned earlier that the STC rating is assigned for the opaque or solid wall or floor component. In 2020, the Ontario Building Code first introduced what's known as a requirement for limiting the apparent sound transmission class rating. And basically what that is it's a measure of the in situ sound transmission. And so when you measure noise within a occupied unit, noise will transfer through what's known as flanking paths. So it'll transfer through intersection of floors with walls. It'll transfer through service outlets in the walls. It will transfer through ducts, for example. All of those areas that Michelle pointed out earlier where smoke will move through, sound will move through those areas as well. And so these flanking paths will often short circuit the opaque section of wall or floor and cause sound to transmit through that wall or floor assembly. The building code in 2020 said you must test for sound transmission and take into account these flanking paths, and it limited the ASTC rating to, I believe, 47 between units. So one of the things that we've found recently is that a lot of complaints are generated from wood frame condominium buildings, more so than concrete frame or non-combustible building systems. That's not to say that that doesn't occur in concrete frame buildings, but it seems to be more of a problem in wood frame buildings. And so why is that so? Well, there are both technical reasons and what I would call regulatory reasons as to why we're seeing this problem in wood frame condominium buildings. Number one, wood frame buildings are lighter. And one axiom of soundproofing design is the more mass you have in a building component, the better the soundproofing will be. And so wood frame buildings are very light. They're discontinuous elements within the wood frame assembly. There's a lot of air in the wood frame assembly. And so by virtue of their the nature of the material and the way that it's assembled, you have a situation whereby you're going to get more sound moving through, more airborne sound moving through that assembly, particularly the low frequency noise that I mentioned earlier. Number two, wood frame buildings involve wall and floor assemblies that have multiple elements. So you'll have gypsum board, you'll have wood studs, you'll have wood joists, you'll have wood sheathing, and all of those components are assembled to form an assembly, as opposed to a concrete building where you have a mass concrete floor slab or a mass concrete wall that's continuous with no breaks. So aside from the technical reasons, there are some regulatory, what I would call regulatory reasons that have landed us to where we are today with regard to sound transmission. In 2015, the Ontario Building Code permitted combustible mid-rise construction. So wood was permitted to be used for buildings up to 6 stories beginning in 2015. I believe prior to that, I don't have the exact date, but somewhere in around in the 2006 Ontario Building Code, 4-story buildings were also permitted to be constructed of wood. However, there wasn't much uptake with the 4-story building, because of economics. But when the building code introduced or permitted buildings up to 6 stories to be constructed of wood in 2015, that opened the doors to a lot of mid-rise wood construction because it was now economical. When you go from a 4-story to a 6-story building framed in wood, the economics are more favorable. So beginning in 2015, we started to see a lot more wood frame construction where you have this condition of stacked units, one above the other. Prior to 2015, we weren't seeing as much stacked construction. It was primarily row house type construction. There were still some stacked scenarios, but not nearly the same number as what we started to see in 2015. However, in 2015, when mid-rise wood frame construction was introduced, the code did not address flanking paths, so it did not address the apparent sound transmission class rating that I spoke of earlier, and it did not address structure-borne transmission. And to this day, the code still doesn't address structure-borne transmission. So we have this cohort of buildings from 2015 till today. So the newer buildings that you see constructed up to 6 stories of wood that still have this problem, really, with structure-borne transmission, and any building built prior to 2020, so between 2015 and 2020, when 6-story wood frame buildings were permitted, they too were not required to address flanking paths. So from 2015 to 2020, you had this cohort of wood frame buildings that were constructed, no requirements for flanking transmission and no requirements for structure-borne transmission.
All right, Mina. Well, thanks for explaining why we have so much trouble with noise in wood buildings. We see a lot of wood buildings in our area. I'm going to switch over to Ivan, and we're going to run a little bit late on the webinar today, but I want to give Ivan a chance. He is a soundproofing expert. He investigates noise complaints. So, Ivan, can you tell us, what does a condo do when they need to investigate a noise complaint to figure out where it's coming from and even how to fix it if it's at all possible to fix it? Ivan?
Yes, Mina mentioned the airborne noise transmission buildings, the STC values. I will focus on structure-borne noise, which most often is caused by mechanical equipment, or often is caused by mechanical equipment. Basically, all cases of mechanical equipment noise are structure-borne noise. And the condo corporation has the obligation to investigate in case there is a complaint against mechanical noise or other types of noises which transmit through structures, such as noise from a gym or previously mentioned garbage equipment, that all create structure-borne noise that needs to be investigated. In some cases, it's quite obvious where the noise is coming from, like, for example, the garbage equipment, that was clear. But in many cases, there is a multiplicity of mechanical equipment in the building: water circulating pumps, rooftop units, chillers, hallway ventilation equipment. Every one of these units potentially could create noise in the residential apartments. So if there's a complaint, the management has to investigate. And the best way to do investigation is get a maintenance person to turn off all equipment which is potentially causing the noise, and then turn it on one at a time, and then either listen or, in better, actually test for the noise presence in the complainant's apartment. And that way you can determine which specific equipment is causing the unit. And that is the first step if trying to fix the problem. Often fixing the problems caused by mechanical equipment are not cheap. They go into tens of thousands of dollars often, because they require installation of the equipment. So condo management often ask me, what is the maximum permissible level at which the complainant should not be really complaining, which is allowed in his apartment? And the answer to this question is not simple, because noise is a complex issue. There are people aspects. Some people are more sensitive to noise than others. Some people are complaining about noise which is by others almost inaudible, but are still complaining about it. So the corporation needs to investigate and determine where the noise is coming from. Often it's mechanical equipment which is improperly installed. Actually, I've never seen an equipment in any building installed following all of the good installation practice guidelines. There is always some area which is less than perfectly installed. So those areas need to be addressed and fixed. Sometimes further investigation is required, which specific element of the incorrect construction is causing the noise. In order to minimize the cost of reinstallation, you have to kind of find the exact point of problem and then follow up and do the proper remediation. So that's basically what I have to say about the noise. The reason why it's so complex, because the noise to the person who is complaining about the noise has many characteristics. There's a temporal, sometimes the noise changes in time. Sometimes there's differences in spectrum of the noise compared to the background noise. Even small differences in spectrum compared to the background noise are audible. They are not necessarily respected by the overall noise level, but if you do spectrum analysis, you see that some frequencies are caused by the equipment to exceed the average level, and that is audible by the complainant. And this is the area which needs to be addressed in solving the problem. So thank you.